Hello everyone. Today we are going to see a bridge pattern. Bridge pattern is basically consists of two things. One is abstraction and one is the actual implementation. So in this case, interface contains an object of the actual implementation. So we have abstraction and that abstraction class is having a refined abstraction methods, and similarly its corresponding implementation will have the concrete implementation class. So let's see this with example. So let's say we have two different types of times. One is a civil time, and one is a public time. So civil time consists of clocks with the 12 hours, and the public time consists of clock with the 24 hours. So let's do that implementation here. So first create a class time implementation. Okay. Now this will have two things. One is hour, and the other is minute. Okay. And we'll have our constructor time implementation, which will take hour and a minute. Okay. Now this will simply copy or update its members, right? And it will have one virtual method, virtual void till the time. And in this, what it will do is it will simply print the time, see out the hours is H, and minutes is M. Okay, so simple displaying we do here. Okay, and that's our simple class which will be created using hour and time. And now this is a base class. We can have the corresponding implementation, different implementation for civil time implementation. So this will simply derive from our time implementation class, and it will have in addition a um, character array which will tell whether it is a AM or PM, right? So we'll take this extra argument here, and the civil time implementation will simply call a time implementation here, and will send these values H and M, right? So hours and minutes will get initialized. And now if it's AM, then we will copy strcpy underscore s. It will copy ch. It will copy AM into it. Else it will copy PM into it, right? So yeah, so that's the civil time convention. And when we say tell, so in the tell it will use we should use protected here so that it gets accessed in the derived class, and it will also display the AM FM, right? mm, I think so. Let's give some gap here and print the ch, whatever is the value of ch. Now similarly we will have a class public time implementation, right? Public time implementation, and this will not have this AM FM thing, AM PM thing, and so it will not have any of these things. It will not have this thing, and it will simply display in some other format. We can assume that, okay, that it has some public time, and similarly here we will have civil time, right? Like that we can have. So these are the two time implementations, right? So now we will have a class time, which will have a time implementation, okay, uh, as member, right? And now this time will basically initialize this member with the new time implementation, right? And here you can again take hours and minutes, and same you can pass it to here, right? So that's your time, right? And here you can have similarly virtual function. Here you will simply call the function of your member, right? And similar to this, we will have the time for civil as well as the public. So we will have a class civil time, which will derive itself from time class, right? Now this is not required, and this can be protected, okay? And here for civil time, we'll need extra boolean, right? Aim, whether it is aim, and this will be now civil time implementation, which will also take this am boolean, right? And here, yeah, everything remains the same. Now, similarly, we will have a public time. So that we should use here. We don't need a AM flag for this public time. And similarly here, we'll use a public time implementation. Okay. So that's the basic idea here that whenever we use this public time implementation, the time um, seems something wrong here. No default constructor exists. Yeah, we'll have to provide a default constructor because we are deriving, right? Civil time. So let's provide these default constructors. So, right. So now, yeah, everything is fine, right? So this is a breach pattern, okay? So this is a time implementation class which provides the method virtual method tell that should get implemented in civil and public time implementation. And similarly, we have time class which will have this as a member, and this member will get in turn called. So now we can create a pointer, right? Pointer, three pointers. So p of 0 p of 0 is equal to new time. So this is a simple time. Okay. P of 1 is equal to new civil time, right? So here you can send maybe it's 2 hours or 14 hours then 30 minutes, right? That's the time. Here it is 2 hours 30 minutes, and it is PM, so it's not AM, right? And P of 2 is equal to new public time, and that should be again 1430, right? So it has some problem conversion. Base class time is not allowed, inaccessible base class time. Why civil time is fine? This is fine. Yeah, this should be public, and this should be public, and that should sort out things, right? And here now you can simply iterate on all the objects, and you can say P of I, tell me the time, okay? And I hope that everywhere we have used slash n, right? So now if you run this, you'll see that hours 14 minutes 30, so that's the base time. Civil time is hours 2 minute 30, and it is PM, and public time is hour 14 and minutes 30, right? So this is how we organize our classes in the bridge pattern. Bridge pattern provides the implementation. So these are some important points in the bridge pattern, that there are two parts to bridge design pattern. One is abstraction, the other is implementation. And this design mechanism that encapsulates an implementation class inside of the interface class. The bridge pattern allows the abstraction and the implementation to be developed independently, and the client code can access only the abstraction part without being concerned about the implementation part. So the abstraction is an interface or abstract class, and the implementer is also an interface or abstract class. The abstraction contains a reference to the implementer. Children of the abstraction are referred to as defined abstractions, and the children of the implementer are concrete implementers. So it increases the loose coupling between class abstraction and its implementation, which is the most important thing, the loose coupling. So whenever you design the classes, there should be less coupling and more coherence, and that is what we are trying to achieve in this breach pattern. Thanks for watching. I hope you got the concept. And